Hello everybody, Mr. Krebsbach here on the 3rd of March. We're in our Supplemental Unit 5, Module 3, Session 1. Today we're going to learn how to find area in a parallelogram. And we'll review what a parallelogram is. Don't you worry your pretty little heads. What you're going to need today before we get started is a math notebook and a pencil. Okay, we've got some examples of some teacher pages that I'm going to go through. What I would like you to do is to please sketch out these parallelograms and take notes on area and how we found them. All right? So, number 1 says that we're going to build this rectangle on our geoboard. Now, obviously, we don't have geoboards that we can get. In your math notebook, I would love if you did that same thing. If you created a 5 by 5 array with those dots, kind of like a geoboard. And then you could just picture around the perimeter or the outside of that shape, the rectangle, are rubber bands. Know that most of you, if not all of you, have worked with the geoboards before, so you just got to pretend a little bit. All right, if you've drawn that out, again, you can pause the video if you need to. Now, it asks us how we find the area. Now, remember, perimeter is the distance around a shape, right? So if we were looking at perimeter, we would say, okay, that's 1, 2, 3 by 2. So 3, 2, 3, and 2. Add those together, you get 5 and 10. So the perimeter would be 10 units. Right? We don't know if those are inches or yards or feet, so we just say 10 units. Now, the area are the little squares, two-dimensional length and width, that are inside of a shape, not the outside, okay? So we can figure out in a rectangle or a square pretty quickly how many units we have. You know, we go across the top, that first row, we have 3, okay? Columns of 2, so that would be 4, 5, and 6. The area would be 6 units. But we also have to say squared, okay, because those are square units. Okay, so a little bit trickier now. We change this rectangle into a parallelogram, and it wants us to find the area in square units, okay? So why it's tricky is we take a look on those ends of the parallelograms, and they're not perfect squares like we have in the middle, right? It's pretty darn easy to see that we've got 4 of those squares on the inside, but what's tough to see is, okay, we're missing a little bit here, we're missing some there, but if you took that triangle and scooched it down here, right, because it's just 1 wide, up 2, okay, we would now have 5 and 6. We would have those perfect squares. So with the parallelograms, we just need to take those triangles, lop them in half, and this is exactly the same. Now, that we've found these, we can do a formula because area is equal to length times width. So we had a length of 3 and a width of 2, and that gave us 6. Same here. We had a length of 3, and then we have to go in the middle for the height, okay? So in the middle, it was still too high. We don't go on the end and say, well, how big is that? No, just go right in the middle, figure out what the height is. So let's take a look at number 3, okay? So again, we go into that middle and we count 1, 2 high by 2, 1, 2 wide, right? So area is length times width, which was 2 by 2. We can say, oh, oopsie, 2 by 2, I was getting ahead of myself and giving the answer. We could say, well, the area is 4 units square, but let's just take a look, okay? Let's go slide that down to the end. Okay, we form that and go here. Gotta get rid of that, and we've got 1, 2, 3, 4. Yes! Now, down here at the bottom, it wants us to create some more shapes, parallelograms in particular, right? They want to record parallelograms that are 3 square units, 2 square units, 9 square units, and 12. But what you can do is you can draw these little dots in a square. Now, this particular geoboard has 5 dots across and 5 dots down. Taking the liberty, obviously, of going over here and saying, okay, they wanted us to build a 3, a 2, a 9, and a 12. Okay, so for a 3 by 2, I know that length times width would be a 3 by 1. So when I start talking about, well, what shape do I want to create? I could say, okay, go over 1, 2, 3, down 1. And there you've got an area of 3. Now, what if you wanted to make a parallelogram? Now, a rectangle is a parallelogram, but what if you wanted to create with the slanted sides, right? So we still would have 3 by 1. And then we would slant it. Okay, so again, we've got a 1, 2, 3 with a height of 1. We would take that piece there and we could say that we've got 3. Simple, simple with the 2. We just need a 1 by 2 or a 2 by 1. If we were making a slanty chanty, we do that. 9. We have one array that could do that here. Okay, we can't quite go 9 times 1, so this is going to have to be a 3 by 3. So let's go across 1, 2, 3. We want to go down 1, 2, 3. So gotta slant it here. That's some fancy drawing. You guys should be doing this in your math notebook. That's a 3 by 3. So 9 units squared. And the last thing that they wanted us to do was a 12. Okay. We could do a 6 by 2, 4 by 3. I don't think, remember there's 5 dots, so we can't do a 6 by 2, so we got to create a 4 by 3. So we go across, 1, 2, 3, 4. Oh goodness, if I slant that, now I'm in trouble. All right, 1, 2, 3. Let's just go with the old rectangle. 12 units squared. Before we move along, as a reminder, we've done this. I actually taught this lesson, I want to say it was in our December number corner. We went and talked about quadrilaterals. Right, there's lots of different quadrilaterals. You could have a trapezoid. Trapezoid has exactly one pair of parallel sides. Okay, quadrilateral is any polygon that has 4 sides. So there's many kinds of them. Okay, the parallelogram we've created, okay, it's 2 pairs of parallel sides opposite of each other. Okay, the rectangle is a parallelogram with 4 right angles. A rhombus is a parallelogram with 4 congruent sides. And then finally, a square is a parallelogram with 4 congruent sides and right angles. Now, when you guys go and do your work on your own, you're going to have to categorize and classify these. Okay, so we've got figure A, and they want to know, well, what kind of a shape is that? Okay, so this is a quadrilateral with exactly 1 pair of parallel sides, so I'm going back to a trapezoid. Now remember, all of these are quadrilaterals, but I don't see that they have listed a quadrilateral. They have parallelograms, okay? So how many right angles do we have? Remember, a right angle is 90 degrees. I see none. How many pairs of congruent sides? Okay, so congruent means the same length. That would be 1. How many pairs of parallel sides? 1. That fits our definition of a trapezoid. Okay, we've got some questions that you're going to answer about quadrilaterals, parallelograms, rectangles, and rhombuses, and then you're going to go to Seesaw, and there's some independent work that I've got for you to complete. Great job taking notes. Have a wonderful rest of your day.